Hey everyone, welcome back to ShareFlare, the channel where you ask questions your way and we answer them ours. Right now, let's jump into an interesting one from Mimboys. How many people would it take to inhale all of Earth's atmosphere? On the surface, it sounds like a simple arithmetic problem, but it turns out to be anything but. The answer hinges on how you define inhaling the atmosphere. Are we talking about removing every molecule of oxygen, or literally breathing in the entire mass of gas surrounding the planet? First, let's pin down the size of Earth's atmosphere at sea level pressure. Scientists estimate its volume at roughly 4.2 billion cubic kilometers, which is equivalent to a sphere about 2,000 kilometers in diameter when compressed to one atmosphere. Why specify sea level pressure? Because gases are highly compressible. When you increase pressure, their volume shrinks. Decrease pressure, they expand. To make any meaningful comparison of how much gas we're discussing, we have to pick a reference, pressure, and by convention, we use 1 atmosphere. Now, how much air does a typical adult breathe? In a resting state, one complete breath cycle moves about 7 to 8 liters of air per minute, which adds up to roughly 11,000 L per day. Over a year, that's about 4 million liters, and across a 70-year lifetime, you'd inhale and exhale roughly 280 million liters of air. If we assume purely for the sake of calculation that every breath permanently removes that volume of air from the atmosphere, then dividing the total atmospheric volume by lifetime intake gives us the head count needed. Crunching the numbers shows you'd need on the order of 15 billion people breathing continuously for 70 years to empty the atmosphere at 1 atmosphere. So picture this, a global team of 15 billion people all taking steady, restful breaths for 7 decades straight. Go ahead, take a deep breath with me. Inhale. Yes, that's it. 2 hours later, oh wait, go ahead, take a deep breath with me. Inhale. 2 hours later. In reality, of course, that theoretical scenario never happens. In practice, humans exhale nearly all the air they inhale, and the atmosphere is constantly replenished by plant life. But it makes for a fun thought experiment, doesn't it? Of course, that calculation is purely theoretical. In real life, humans exhale almost everything they inhale. Of the roughly 11,000 L of air an adult breathes each day, about 10,450 L gets blown right back out, and only around 550 L of oxygen juiced. 5% of that intake is actually absorbed to fuel our metabolism. Plus, atmospheric oxygen is in a static reservoir. Tiny marine plants called phytoplankton churn out NuO continuously, offsetting what we consume. And biologically speaking, humanity would vanish long before we'd sniff out all the air. Anyway, for starters, we exhale 95% of what we breathe in, so we'd never permanently remove enough gas. Then there's the fact that phytoplankton in the oceans replenish oxygen faster than we burn it. Finally, if the atmosphere's O level dipped to below about 16%, even sedentary people with struggle cells simply wouldn't get enough oxygen to keep working. And at 10 to 14%, breathing becomes erratic. Drop to 6%, and survival becomes impossible. In short, the planet has plenty of breaths to go. Next up, from Minla, why don't satellites crash into each other? And how many could we theoretically launch? As of April 1st, 2020, there were roughly 2,663 satellites orbiting Ertebau, 1,327 from the US, 363 from Canada, 169 from Russia, and 807 from other nations. Vietnam contributes 3, Vinasat 1, Vinasat 2, and VNRESAT 1. You might think 2,600 objects drifting above us sounds like a recipe for cosmic bumper cars. But space is vast, especially the low Earth orbits, where most satellites operate. Engineers place each satellite into a carefully chosen orbital lane that avoids existing paths, minimizing collision risk. However, orbits can shift over time, and decommissioned satellites may lose maneuvering ability. So impacts, while rare, do happen. The first major satellite-satellite collision occurred on February 10th when the active Iridium-33 and the defunct Cosmos 2251 slammed into each other at about 11.7 kilometers per second over Siberia. That smash-up generated over 2,000 debris fragments larger than 10 centimeters and thousands more tiny shards, illustrating the danger of untracked junk. In theory, you could keep launching satellites indefinitely as long as you map out non-intersecting orbits. In practice, though, we're approaching the thousands. SpaceX alone plans up to 42,000 Starlink satellites to blanket the globe with high-speed internet. Amazon's Kuiper project eyes over 3,000, and OneWeb aims for 57,000 satellites in low Earth orbit within the next decade. With that many objects sharing crowded lanes, collision avoidance maneuvers will have to ramp up from today's 3 per day per satellite to perhaps 8 per hour. This looming congestion brings us to the Kessler Effecta, 1978 scenario proposed by NASA's Donald J. Kessler, where a single collision triggers a chain reaction of debris on debris impacts, exponentially increasing space junk. To avert this domino effect, experts recommend that 99% of satellites be actively deorbited at end of life, ensuring they burn up harmlessly in the atmosphere rather than littering orbital highways. Alright, let's tackle a truly mind-bending question from Alex. If you could continuously replace every part of your body except your brain, could you become biologically immortal? First, what do we mean by immortal? Absolute immortality means never die and no accidents, no disease, no aging. That's pure fantasy, the realm of gods and Biological immortality means your age-related mortality rate stays constant or even decreases over time. You can still die from trauma or infection, but you never grow old. This is the concept science is exploring. In our thought experiment, you'd swap out skin, muscles, bones, and organs, everything except your brain. Could that let you live forever? The real challenge lies in the brain itself. Neurons are largely they don't divide to renew themselves. Most of the neurons you're born with stay with you for life, accumulating wear and tear, oxidative damage, protein clumps, DNA lesions. Even if you replaced your entire circulatory system, lymphatic vessels, cerebrospinal fluid, and kept your immune system flawless, any damage inside a neuron can't be diluted or discarded via cell division. There's an intriguing animal study hinting at neuron resilience. Researchers transplanted cerebellar, precursor cells from a 1.5-year-old mouse into a 3-year-old mouse's developing brain. Those donor neurons survived 36 months, twice their expected lifespan without issue. It suggests a nurturing environment can significantly extend neuron life. But extrapolating from mice to humans whose longest-lived brain we've observed topped out at 122 years remains. Beyond cell survival, the brain relies on complex support systems. Mitochondrial health. Neurons need constant Mitochondria accumulate mutations over time. And since neurons don't divide, you can't just swap in fresh powerhouses. Lymphatic clearance. This nightly waste removal system clears toxins and protein If it fails, neurodegeneration follows. Blood-brain barrier integrity. Tiny leaks let inflammatory molecules in, damaging neurons over time. Even if you could periodically rejuvenate every non-neural component, heart, lungs, kidneys, blood, the bottleneck would remain the brain. Neural stem cells exist only in limited pockets, unable to replace billions of damaged neurons across the cortex. Some transhumanist visions propose mind uploading to a digital substrate or cryonic suspension of the brain until future tech can repair it. But digital copies raise philosophical questions about identity, and cryonics offers no proven revival method. In short, swapping out everything but your brain might stall most aging processes, but true biological immortality hinges on preserving or regenerating neural networks, something we can't yet achieve. The dream of endless life remains tantalizing, but for now it lives on in speculation and science fiction. And that's a wrap on our deep dive into 3 wild what-ifs. From breathing away Earth's atmosphere, to the crowded highways of satellites above us, all the way to the tantalizing dream of replacing everything but your brain and living forever. Whether it's mind-boggling, math, orbital mechanics, or the frontiers of neuroscience, these thought experiments remind us how astonishing and resilient our world really is. If you enjoyed this journey through imagination and science, give this video a thumbs up, hit subscribe, and ring that bell so you won't miss any future Got a question of your own, or a crazy what-if we should tackle next? Drop it in the comments below. I read every one. Thanks for watching ShareFlare, and until next time, keep wondering, keep exploring, and stay curious.